In this video, we have two trigonometric equations to solve for solutions in the interval from 0 to 360. So we use some basic algebra and some trig identity to solve both of these equations. So first of all, it makes it a lot easier to solve a trig equation if you have just one trig function instead of two. Not that you can't do it. Sometimes you factor and the two functions are separate. In this case, what we're going to do could go either way here. I could get it in terms of sine. I could get it in terms of cosine. I'm going to use the trig identity. It tells me that cosine squared of an angle plus sine squared of an angle equals to 1. So that'll be cosine squared of any angle. In this case, we'll use x. Could be theta in some cases, depending on what you're given. So it's your fundamental Pythagorean identity, or one of them. So notice this tells me that I can solve sine squared for cosine squared, or I can solve cosine squared in terms of sine squared. So taking this over, I can see that cosine squared of x is equal to 1 minus sine squared. So this cosine squared can be replaced by 1 minus sine squared of x. This will be equal to 3. And so now multiplying through here by 3, this will give me 3 times 1 will give me a 3 here. So this will be 3 minus, multiplying by 3 again with the sine squared. Get minus 3 sine squared of x equal to 3 here. And I got a minus 3 sine squared here and a plus sine squared of x. So let's add these two together. So that'll give me a minus 2 sine squared of x. Those combine. 3 and 3 will give me 0. Or I should say 3 minus 3 will give me 0. Now, I was taking this over to the other side, change the sign, I get a 0. And then I can just divide through by negative 2, and I get sine squared of x equals 0. So I'm looking for solutions in the interval from 0 to 360. So I want the sine of an angle, and then I'm going to square it. I want to get 0 in the interval from 0, including the 0, but not the 360. So what is the angle, in this case x? So what angle has a sine of 0? When I square it, I'm going to get 0. So that angle would be 0 degrees. Sine of 0 degrees is 0. Square it, I still get 0. And then the other one would be 180. Sine of 180 is 0. Square it, I get 0. So this one, these two check out. Now those are two in the interval from 0 to 360. Keep in mind that if a trig equation has a solution, it has an infinity of solutions because the function is periodic. We just add a multiple of the period and we get another solution. But we're only interested in the ones between 0 and 360. So that's the solution for this one. Now in the same way here, for number 2, we have the function cosine and the function sine. So using some trig identities again, I'm going to use the same identity. I've got the square root of 2 cosine of x. So I'm going to put everything in terms, in this case, in terms of cosine. So I've got a cosine there, cosine over here on this side, and then the minus sine squared by that fundamental identity we just used. This can be replaced by 1 minus cosine squared of x. And this one stays the same, cosine squared of x. Let's rewrite this then. Got the square root of 2 cosine of x. Multiply through, distribute the negative here. This will be a minus 1 plus cosine squared of x. And that's equal to cosine squared of x. So now I have everything in terms of cosine. Again, could have done it in terms of sine. Still would have worked out. So now we can go ahead and simplify this a little further. Notice I have a cosine plus cosine squared here and a cosine squared x on this side. Take this over to the other side, that's going to cancel. Those will cancel. Take the minus 1 over. So that leaves me then with square root of 2 cosine of x is equal to 1. Taking the minus 1 over. Then I can go ahead and divide by the square root of 2. So this gives me cosine of x is equal to 1 over the square root of 2. And then be familiar with your reference triangles, 45, 45 right triangle, the 30, 60 right triangle. Or just memorize that if I have a 45 here, this is 45 degrees here. This equals will be also 45. And this is a 1, and this is a 1. Then this will have to be the square root of 2. And this is 45 degrees here. So I know that the cosine then of 45 degrees is equal to 1 over the square root of 2. Adjacent over the hypotenuse. This right here. So I know then that an angle that has that value is 45 degrees. So you can treat 45 degrees as your reference angle. That would be in quadrant 1, so that's 45. In the first quadrant, all the trig functions have a positive trigonometric value, as long as the terminal side lies in that first quadrant. Now, I can put the reference angle over here, 45, quadrant 2, then this angle here would be 135, and that would have a cosine of negative 1 over the square root of 2. Or I could put the reference angle over here in quadrant 4, and then look at this angle. This angle here then would be 45 degrees, so that this angle over here in the fourth quadrant is 350 degrees. So the two angles in the interval from 0 to 360 that satisfy this equation are 45 degrees and 315 degrees. If there's no restriction, it's infinite. I would just add a multiple of the period for the function of cosine, which is 2 pi, or 360 if you're dealing with degrees, which we are here. So the only two values or solutions that we give are x equal to 45 degrees and x equal to 315 degrees in this particular interval. Thanks for watching. We'll see you next time.